Is time travel only a figment of our collective imagination, or could it actually be a reality? This question has captivated the minds of many, from scientists to science fiction enthusiasts. It's a concept that's been popularized in countless novels, films, and TV shows. From H.G. Wells' The Time Machine to the Back to the Future trilogy, the idea of hopping between different points in time has always been a tantalizing prospect. But to truly grasp the concept of time travel, we must first understand time itself. Time is not just a ticking clock or a flipping calendar page. It's a dimension, much like length, width, and height. We move through time every second of every day, but unlike the other dimensions, we can only move in one direction, forward. The question then becomes, can we alter this one-way journey? Can we reverse, stop, or even accelerate it? Dive into this fascinating journey with us as we explore the reality of time travel. Now, let's delve into the physics of time travel. Time, as we understand it, is more than just the ticking of a clock. It's actually considered the fourth dimension, a companion to the three dimensions of space we're accustomed to. We move forward in time, constantly and unstoppably, just as we can move forward in space. But could we ever move backward in time, just as we can retrace our steps in space? Albert Einstein's theory of relativity provides some intriguing insights. Einstein suggested that space and time are not two separate entities, but are interwoven into a single continuum known as space-time. Objects, including you and me, move along this space-time continuum. Here's where it gets exciting. Einstein's theory also suggests that large amounts of gravity, such as that produced by a massive star, can actually distort or bend space-time. This results in what we call gravitational time dilation, where time moves slower the closer you are to a gravitational source. This is not just theory. It's been tested and confirmed with precise atomic clocks. This leads us to the most thrilling possibility: wormholes. If space-time can be bent, then it could be bent into a tunnel-like shortcut between 2 points. This is what we call a wormhole. Imagine folding a piece of paper representing space-time and poking a hole from one side to the other. That hole, that shortcut, is the wormhole. Wormholes could, theoretically, allow for rapid travel across vast distances of space. And if they could connect points in space, why not points in time as well? This is where the concept of time travel comes into play. Theoretically, if one could create or find and traverse a wormhole, one might emerge in a different time as well as a different place. While physics may allow for the possibility of time travel, it is the technological challenges that currently hold us back. So, what are the technological bottlenecks that are keeping us from hopping into a time machine? Well, let's consider the energy requirements first. For a time machine to work, we would need to create a wormhole, a shortcut through space and time. But to open up a wormhole, we'd need something called exotic matter with negative energy density. Now that sounds fancy, doesn't it? But the truth is, we don't even know if such a substance exists. Even if it does, producing it in the required quantities would be a monumental challenge. And then there's the question of stability. In theory, wormholes could collapse rapidly, without warning. So, we'd need to devise a method to keep them open long enough to allow for safe passage. This might involve technologies so advanced, they're currently beyond our wildest imaginations. But let's say we somehow overcome these hurdles. We create and stabilize a wormhole, and we're ready to step inside. What happens next? Well, that's where we encounter yet another challenge, the unknown. Theoretical physics can only take us so far. What lies beyond the event horizon of a wormhole is a mystery. It could be a gateway to another time, or it could be a one-way ticket to oblivion. And the uncertainties don't stop there. What if, by traveling through time, we change the course of history? What if we cause a paradox that unravels the very fabric of existence? These are questions that technology alone can't answer. And finally, there's the issue of scale. To date, the only evidence of wormholes comes from the quantum realm, where particles are so tiny, they're almost negligible. Scaling that up to accommodate a human, or even a spacecraft, would be like trying to thread a needle with a rope. Although the technology isn't there yet, what if we could actually travel through time? What would that look like? Imagine stepping into a time machine and changing history. But could we really alter the past or the future? Let's delve deeper into the consequences of time travel, starting with the concept of alternate timelines. If time travel were possible, it could create an infinite number of parallel universes, each representing a different outcome of every decision ever made. But what does this mean? Well, imagine you travel back in time and decide to have a peanut butter sandwich instead of jelly. This seemingly trivial decision could create an entirely new timeline where peanut butter becomes the world's favorite spread, not jelly. It's an amusing thought, isn't it? But it also showcases the potential of time travel to create a web of realities that are as limitless as they are bewildering. Now let's tackle the paradoxes associated with time travel, such as the infamous grandfather paradox. Imagine going back in time and accidentally causing the death of your own grandfather before your parent was born. This would mean that you could never have been born. But if you were never born, then who went back in time? It's a loop that seems to defy logic, creating a paradox that challenges our understanding of time and causality. Speaking of causality, let's explore its role in time travel. Causality is the principle that everything happens for a reason. It's the idea that every effect has a cause and every cause has an effect. In the realm of time travel, messing with causality could lead to unpredictable and potentially disastrous consequences. Imagine causing a chain reaction of events that could lead to the extinction of dinosaurs or the non-invention of the wheel. The ripple effects could be immense, altering the course of history in unimaginable ways. So, as we ponder the possibility of time travel, we must also consider its potential consequences. As fascinating as time travel sounds, its implications could be far more complex than we can comprehend. Time travel, then, isn't just a question of when, but also a question of how and why. And these are questions that we'll continue to explore as we journey through the mysteries of time. So, where does this leave us? Is time travel real or fiction? In the grand tapestry of our exploration, we've delved into the enigma of time travel, the underlying physics, the technological bottlenecks, and the potential consequences. Let's take a moment to summarize these intriguing facets. Time travel as a concept is no stranger to the realms of science fiction. The notion of hopping between different points in time has long captivated our imagination, sparking a myriad of stories and theories. Yet, it's not just a figment of our creative minds. In the world of physics, particularly within the framework of Einstein's theory of relativity, time travel holds a theoretical possibility. However, bridging the gap between theory and reality is a formidable challenge. The technological hurdles we face are gargantuan. Harnessing the energy required to warp space-time, building a machine that can withstand such extreme conditions, or finding a naturally occurring wormhole and somehow managing to keep it open. These are monumental tasks that currently seem insurmountable with our existing technology and understanding. There's also the butterfly effect to consider, the idea that even the smallest action in the past could drastically change the present. This introduces a whole new realm of ethical and philosophical dilemmas. Despite these challenges, our quest for knowledge continues. Around the globe, scientists and researchers are tirelessly working to unravel the mysteries of time. Their efforts range from theoretical physics and quantum mechanics to cutting-edge engineering and technology. While we may not be ready to pack our bags for a temporal journey just yet, the ongoing research in this field is undoubtedly pushing the boundaries of our knowledge and understanding. Time travel captivates our imagination and drives us to explore the boundaries of science and technology. The journey to uncover its reality is as exciting as the concept itself.